Hello, my name is Antti Alamaki. I'm a senior lecturer in physiotherapy in Karelia University of Applied Sciences, and I have worked together with our Ulster University friends in SENDOC project now about 3.5 years. Joan and James asked me to tell you some reflections concerning use of wearable sensor systems in neurological physiotherapy. And we have used mainly wearable sensors, analyzing and monitoring the aspects of walking with the neurological patients, also with surgical patients, actually any kind of patients who have problems of walking or fall risk, etc., etc. We have used two kind of sensor systems in various environments. I should say that maybe a couple of hundred patients, maybe couple of from 1 to 2,000 therapy sessions. If you think about the environments or organizations, we have used those sensor systems, especially in remote home rehabilitation, in older persons and disabled persons who are living in service homes, both on the spot and remotely. We have used those sensor systems in acute hospital wards, in rehabilitation hospital, in open physiotherapy sessions, both private and public. And we have in our university therapy service unit with whom's customers we have used these sensor systems. And we have already included some sensor systems to physiotherapy education programs and courses where our students are working together with their patients. When you think about the reasons or the goals of using wearable sensors, I should say that, of course, there is always a demand that therapy and rehabilitation should have a very variable effectiveness. The politicians, the persons who decide the resources, needs to see the numbers, the real knowledge of the effectiveness in different organizations in order to give enough resources, etc. So this is maybe a community view of there is the use of wearable sensor systems. When you go inside the therapies, of course, the key factor is to be able to monitor the customers or patients' functional capacity, how the therapy is going on, how to individualize the exercises, the therapeutic exercises, in order to achieve as good results as possible. If you think about neurological patients, but any patient that has difficulties of walking, of course, the key goal of therapy is to achieve as safe and qualitatively good walking as possible. In the consideration of what kind of environments the patient needs to be active. Of course, you can include the wearable sensors measuring when you are evaluating what kind of assistive devices could be useful to the customer in order to achieve the as safe walking as possible. In some level, of course, you meet also the demands of the environment where the person originally lives. Is he or she able to continue the living there? So as I told you, we have mainly used two kind of sensor system. One is MoveSole smart insole system, where there is insoles where there are 7 sensors analyzing the ground forces or below the foot, and it's connected to application of a mobile phone. The other is this MoveSole system is a Finnish developed and manufactured system. Then an Italian system, G-Walk, which is one sensor system for analyzing spatiotemporal parameters of gait. There is also other tests built up in the algorithm. This one sensor is connected to usually a tablet computer or a normal computer by a Bluetooth connection. These both systems work or so-called discuss the connection with Bluetooth connection with the application. Here is first a picture of this MoveSole reports. As you see on the right, there is this main view of the report or the application. You can see there the weight distribution of included steps, which might be, for example, 10,000 steps or less. The average weight distribution of maximum vertical force, ground force between legs. And for example, in this example, you see that the patient is transferring the weight heavily on the right side. You can see also the peak ground forces and the distribution of ground forces between those different 7 sensors, from where you can a bit analyze the position of foot and the function of foot during the step. On the left-hand side, you see the typical curve. The first highest point is heel strike, then there is mid stance, and then there is toe off phases. And in the below line, you see the time of step, the average time of step, the average heel strike ground force, mid stand ground force, and toe off ground force. As you probably remember, a person during normal walking, a healthy person, the highest force level is approximately 120% of his or her body weight. So those are the basic knowledge, basic analysis, what you can see in the Smart Insole. Here is just an example how one patient situation, of course, this has going on especially good. The asymmetry has been quite heavy in the beginning, and then after rehabilitation and exercise period, you see in the right hand side what is the symmetry situation in the end of the rehabilitation period. In the middle of the picture, you can see that in first analysis there has been 600 steps, and you see a step by step how, for example, probably the tiring of the patient has grown the difference between left and right step. And then after the rehabilitation period, in the end of the rehabilitation period, you see that there is about 3,000 steps, and when you check the change in the difference, you see it's much better situation now. So this is an example for monitoring the impact of physiotherapy sessions. You can also monitor, for example, person who is doing, for example, exercises that are connected to improve the walking. You can see how the weight distribution is going, for example, in squatting or doing mini squatting or doing other exercises that are connected to improve the walking. Then here is example from a report of G-Walk. You can see that there is also a quality index, which is counted from the percentage of the swing and stance. Then there is analysis of dual stance and single stance. There is cadence, there is walking speed, which is very good parameter to follow. Then there is step length, stride length, percentage and centimeters. And then there is a symmetry index concerning the propulsion direction. And then interesting part is that there is also this pelvic movement analysis, where you can very often see various kind of compensative movements of different problems. The good part is that there is also always reference knowledge in these reports, so you can a bit almost immediately see both patient and yourself what are the key findings compared to reference numbers. Well, as a summary, the positive points in MoveSoul have been especially that it has been very motivating for the patients to see the numbers change, hopefully for the better. You can have a longer period analysis and monitoring, and in real environments. Compared to very many other insoles, the MoveSoul insole is very thin, so you can, and it's flexible, so you can put it in various shoes, in various insoles, etc. It's relatively durable, it's hygienic, you can clean it after every use. It's easy to put on and take off. The activating the application and the connect to application is very easy and simple. You don't have to very much push different buttons or give different orders in the smartphone. And the basic interpretation of the report is quite easy to understand, both for the staff and for the patients. Few negative points: the battery usage is quite annoying. You have to change the batteries considerably often, and because you are not able to load them. Sometimes the shoe and the foot shape is a bit different than the actual insole shape, especially the wide foot are sometimes so wide that they don't hit the right sensor correctly. And of course, considering the different aspects of walking, there is a little bit limited amount of parameters. And one thing that has been improving is that if the person is walking very, very slowly and the step time is very long, we asked the company to continue the step time, because it has impact on how and when the sensors are so-called awake. So in very, very slow walking, it still might be a problem, but not very often, because they continued the step time part in the algorithm quite a lot. Concerning the G-walk, approximately the same positive points. Longer period of monitoring in real environments. Certain parameters are quite accurate and reliable. There's only one sensor to put on. There's a lot of different kind of parameters to analyze. It's easy to put on and take off, but you have to have, in some cases, assistance in order to put it in the actual correct place, because it has a lot of impact to the results. The basic interpretation of the report is easy because there has been physiotherapists who have been participating on planning the report, and it's directly connected to those factors that has impact of quality of work. The negative part is that there is many phases, many steps to proceeding in the measuring, so you have to give more usage guidance. There are some parameters that are not so accurate, so you have to be a bit careful in those parameters. About the accurate placement, I already told you something. And then there is this problem that if you want to connect online measuring and online wiring, it's a bit difficult. You cannot connect them to remote connections equipment. The only possibility is to show it, so show this report to camera, or print the report in the paper and show it to camera, or send it to the remote therapist by email. Now I've already taken more of my time, but shortly here is my show. There is probably familiar references for you, but anyway, I included it there. Thank you for your interest and have a nice summer.